today we will start. This is the last concept in this class, and this is an exam problem that I will try to explain ANOVA two-way. A new fertilizer has been developed to increase the yield on crops and bushels per acre. This is the unit for the yield of crops. And the makers of the fertilizer want to better understand which of the three formulations, blends of this fertilizer are most effective for wheat, corn, soybeans, and rice. They test each of the three blends on one sample of each of the four types of crops. The crop yields for the 12th combination are as shown below. So I will go and show it from Excel. So we'll show it to you now. We go and switch to Excel. Okay, so this is the sample. Now I'm going to do a two-way ANOVA. Why? Remember the one-way ANOVA, we have one factor. Here, we have the fertilizer, we have phosphate fertilizer, we have potassium fertilizers, and we have nitrogen fertilizer. And we have wheat, we have corn, and we have soy, and we have rice. And this is all the yields. Okay, so if we have only phosphate fertilizer and 1, 2, 3, 4 crops, now this is a one-way ANOVA. But if we have 1, 2, 3 in the side and 1, 2, 3, 4 in one side, we should apply the two-way ANOVA with replication. So let's apply this technique and we'll see what will happen in this analysis. So we go to data analysis, and then ANOVA, don't use single factor. Now we have two factor with replication. Okay, so the input range, we will put the input range from the title here all the way down. So I'll just make it again. It's like this. You take the title and you go all the way down to the last number. And then rows per symbol. Now we're going to go to each one of them. Let's say here, 1, 2, 3, 4, 5. Of course, the other one has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can see it all. For every fertilizer, there is 5 rows, measurements. So 5, we'll put here 5 rows per sample. Alpha, of course, we're going to use 95% confidence level, so I'm going to put 5% or 0.05. The output range, I will select the output range here. Okay, so I'll select this one and I will say okay. So now, just make it bigger, a little bit bigger here, so the thing will fit. We can see from our analysis that we have the summary for the phosphate fertilizer. This row, we have the average for wheat, 131.8 bushels per acre. This is the unit for the yield. Corn is that much. This is only for phosphate fertilizer. And soy is that much. Rice is that much. This is the average and total for all of them. For potassium fertilizer, we have the count sum, but the average is the most important thing. Same thing for nitrogen fertilizer. We have it here. Now, total, everything together for wheat is 146, 156 for corn, soy 167, and 160 for rice. Now, this is this is the most important table in the ANOVA. You can see here the samples 0.000245 the P, and you can see the F statistics is higher than F critical. This is significant, and we'll be talking about this now once I'm going to start writing the results. Now the sample is significant. Now, how about the columns? The columns is not significant. It's higher than 0.05, while the interactions between each other, between the fertilizer brand name and between the type of the food production yield, and that is there is significant interactions. And you can see also that F is a little bit higher than F critical, but this is statistically significant at 5% or at 95% confidence level or at 5% alpha. Now, so these are the things we looked at. We should look at 0.05. Now let's go and show you my results. How did I write the results? So we go. So we go to Word. Okay. This is the problem that we showed you, and then of course blend X. We call it a blend X, the name of fertilizer, blend Y, and blend Z. But this is what's going to happen if you have a question. But let's see the results. Now we'll talk about the first one, sample. Look at, maybe I just put that down, so I should put it up. This one should be up. So since the p-value of the blends of the samples, okay, is 0.00025, which is less than 0.05, and that's alpha, we reject the null hypothesis. We reject that they are similar. Okay, so between all three fertilizers, there is a huge statistical significance. But how are we going to write it down in the results? Since the p-value blends, or since the p-value fertilizer brand names, it's equal, the p-value is equal to 0.0025, which is less than 0.05, equal to alpha, comma, we reject the null hypothesis and conclude that the blends are statistically different. Okay, now this is the good result. Let's look for the second one. Remember the second one? Now, this is the samples, fertilizer X, fertilizer Y, and fertilizer Z. Now, let's look at the crops. Okay, at the columns now. So remember the columns was 0.0049, 0.0649, sorry. This is higher than 0.05. So there is no statistical significance between the crop yields. But who cares now? We found that there was a statistical significance between using any of these blends of fertilizers. But since the p-value crops equal to 0.0649, which is higher than 0.05, equal to alpha, we cannot reject the null hypothesis. معناها they are equal, which means that they are equal. All the blends are equal. All the food type are equal. We cannot reject the null hypothesis and so conclude with 95% confidence that there are no significant difference between the effectiveness of the fertilizer for the different crops. Good now? So we go to the next one. The third one, the interaction. Remember, the interaction was very close, 0.0456, very close to 0.05, but still it's lower than 0.05. We also see that the p-value for the interaction is equal to 0.04565, 0.0456, less than 0.05, equal to alpha, and so conclude there are significant differences in the interaction between crop and blend type. We can look more carefully at the interaction by plotting the mean interactions between the levels of the two factors. Now there is interactions. You could see that the interactions is very small but significant. Okay, and it is significant at 95% confidence level. You can see the lines. This is an extra plot. You can see here from that there is a trend. Anything that's parallel, you can see there's no interaction. But when you see things going up and then down, this is an interaction. So what are we going to do? Lines that are roughly parallel are indicators of lack of interactions, while lines that are not roughly parallel indicate interactions. See it from here? See this going down and then up for the soy. Of course, it went down because of the blend, the second blend, while it was up for the first blend, and it went high up in the second blend. This is for the soy. So these things and the blends with each one of them, you can see that these parallel things, you can see that there is no interaction, but this huge interactions of the soy made the B value more significant. Same thing here for blend X versus blend Y. Okay, while you can see that blend Z and blend X, they are not parallel, but okay, there is no touching between the lines. While there is a huge touching between, there is a huge change of increase and decrease in blend Y. So this is a nice example of interactions between different fertilizer and different crops. From the first chart, you see that we can see that the potassium fertilizer has a quite different pattern from other. This is, it should be written in the conclusion. And just writing these curves and using Excel is very simple. Has a quite different pattern from the other brands, especially since the line of potassium fertilizer is trending up. You can see it trending up and up toward soy and then down toward rice. Exactly the opposite of phosphate fertilizer and nitrogen fertilizer. We also see that the phosphate fertilizer is trending up towards soy much more appropriately than nitrogen fertilizer. This is like part of the results and discussion. Hope that you understand the way we use ANOVA two-way, and this is one of the most important. Well, it's a very important test, and you need to use it a lot if you are doing project or thesis. So thank you very much for attending this, and hopefully you'll use it a lot.